Hello and welcome to our next section of our circles unit. We're continuing chords and arcs. Last time we talked about congruent central angles and the components that would also be congruent based off of congruent central angles in same circles or congruent circles. Chords, for instance, chords and arc measures would also be congruent for those specific central angles. But anyway, we're continuing and we're going to talk about equidistant chords from the center. So let's first draw a circle. And I don't have a lot of battery left, so let's try to make this a quick one. We have a circle here. Center of the circle is O, and we're gonna say, for instance, we're gonna draw two different chords. If we have two chords, let's call this A, let's call this B, and we are going to draw a second chord. Remember, a chord is a line segment where the endpoints are points on the circle. Let's call this C and D. And in these two particular chords, we are going to say are equidistant from the center. So the shortest distance from the center would be perpendicular to the segment, to the chord. So if I drew, for instance, a line that connects the center to AB, it would create a perpendicular angle. They would be perpendicular to each other. The same thing would happen here. If I drew the shortest distance from the center to the chord, then it would be perpendicular. So, in this particular case, we would have if we had two chords, if we had two chords that were equidistant, meaning they had the same distance away from the circle, or from the center, then we would actually have congruent chords. So, if these two distances were the same, let's actually put some endpoints here. Let's call this E, and let's call this F. Okay? For instance, if EO was congruent to FO, then we could definitively say that AB will be congruent to CD. That's what it means by equidistant chords from center. So this is our theorem. Equidistant chords from center. All right. So if we have equidistant chords from center, this states if chords are equidistant, from the center, in a circle, and then I'm going to put this in parentheses, or congruent circles, so it could be two separate circles that have the same size. So this is an if-then. Then the chords are congruent. Okay? Now, as I stated, in this example, we could say if OE is going to be congruent to OF, then AB is going to be congruent to CD. Okay? Now, if you remember from when we did our conditional statements, we could always look at the converse. And in this particular case, the converse would also be true. So this is a little note. Converse is true. So we could flip the if and the then. So that would make this a true biconditional. So we could switch if and then, and this would still be true. So this would look like this. I'm going to do this in blue. If AB is congruent to CD, or the chords are congruent, then they would be the same distance away from the center. OE would be congruent to OF. Okay? So that is your equidistant chords from the center. Pretty much it's like a theorem. Kind of straightforward, kind of stands alone. And this pretty much equidistant from chords from center tells it all. We also have another theorem that we should talk about, and that is the chord perpendicular to the diameter. So let's draw another circle. Okay, so if you ever have this situation where you have the chord, any chord, that is perpendicular to the diameter. Okay, so let's make this a little, a little section in a circle. If a diameter that looks really weird. Diameter is perpendicular to a chord, then it bisects the chord and its arc. Okay, so let's break this down. We need a center of our circle because we definitely have to work with the diameter. So let's call this O again. And let's draw a diameter. Here's our diameter. Let's draw a chord. A chord that is perpendicular to the diameter should create right angles all around. I'm only going to draw one. It should be implied that all the angles in this intersection are right angles because of the one. So what happens here is if this chord, or if this diameter is perpendicular to the chord, so I'm going to highlight some pieces. If this diameter, let's get a bigger piece. If this diameter is perpendicular to the chord, then it bisects the chord and creates two congruent pieces. So this would say if, so here's your example. Oh, and I should name some pieces here, huh? Let's call this A, let's call this B, let's call this C, let's call this D. Okay? And then we could say if AB is perpendicular to CD, then we could say, oh, I forgot one. Let's call this one E, this intersection. Then EC will be congruent to ED. Okay? We could also say, so this would also work if this is the same statement. AB is perpendicular to CD, then the measure, because it's arc measure, and let's highlight this in blue. Oops, yep, that's right. We could say, then the measure of AC is going to be congruent to the measure of AD, because those two arcs will be congruent. Okay? So that's a different theorem. Our chord diameter. We have perpendicular diameter to the chord. Now the last one that we're going to talk about today is if a diameter bisects a chord, that is, so here, let's just write it out. If a diameter bisects a chord, so in this particular case, we don't know that the right angle is there. All we know is AB would be bisecting CD. And we're going to note here that is not another diameter, because you could have multiple diameters. Another diameter. And I'll explain this in a second. Then, oops, it is perpendicular to the chord. Okay, so here we're going to state, let's do this in green, if AB, which is the diameter, if AB is the diameter, if AB is the diameter and CE is congruent to DE, then AB has to be perpendicular to CD. Okay, so what's happening here? We're saying, I'm going to erase this right angle. We are now saying, okay, this right angle's gone. We are starting off with the statement. Oh, let's use purple. We have a diameter, and then we have a chord that is broken up into two congruent pieces. If that's the case, then a right angle is formed from the chord and the diameter. Now, the reason why we add this little caveat here is that we have to make sure that it is not another diameter. If I drew another diameter here, it would technically bisect. The AB bisects this new purple diameter, right? And they actually bisect each other, but these are not necessarily perpendicular. We could clearly see that it is on some kind of extra angle, more than 90 and less than 90, so it doesn't necessarily mean that it forms a right angle. It has to be specifically a chord and a diameter. They have to be both of those cases. Okay? All right. So that's all I have for you today. If you have any questions, please let me know, and I will see you in the next one. Bye.